Alrighty, so hopefully this talk will move at a quicker pace than the last one and not by me talking faster. What I wanted to show here real quick was, hey, you can do distributed Python if you're a data scientist or you're trying to figure out how to massage data in Python and you want to be able to get higher performance than the machine you're on otherwise would have had by parallelizing your tasks. You can use DASK to do that, and I'm super lazy and don't want to install anything on my machine, so I just run DASK in Docker, and that way I don't have to install anything. I just have Docker running. I run a Docker compose command, and I've got a multi-node, multi-threaded Python environment with a Jupyter notebook installed in it. For this one, I'm actually going to show doing the work in Visual Studio Code, remotely connecting to the Docker container and remotely running and editing and running the code. Okay, so in this case, I've kind of sized this thing up. We're going to pretend we're in the cloud. I've got my Craigslist find still here, which I way over. You know, when you find stuff on Craigslist, you're always just like, oh, I got it to bring it home with me. It followed me home. So this one's got 16 cores that we've got allocated to this process. And what we're going to do here is we're going to spin up a DASK, distributed Python environment, with a task scheduler. So it'll actually farm out tasks to the worker nodes, and we've got 2 worker nodes. Each worker node will be automatically sized to have the number of threads equal to the number of CPUs that are available. Since we allocated 16 cores to Docker, dude, this totally works with like 2. I do this on my Ultrabook all the time, but for this I jacked it up, and so we'll have 2 worker nodes with each with 16 cores. And I've got a Jupyter Python server, and really what I'm going to do is I'm going to use that Python server as my target machine to edit the code, and then that code is actually going to make remote calls to the job scheduler and push the code off into the nodes. Okay, so here's Docker stats. We can see we have nothing running right now. I'm going to come over here, and I have not done this like as a warm-up. I did it the other day, and I'm hoping this will work out. Okay, so we can see in Docker we currently don't have, so this is pointed at my local Docker. This is Visual Studio Code with Docker and the remote packages loaded on it, and Python, of course. And what we're going to do is we're going to spin up this environment, and my local GitHub will get mounted onto the Python server so we can run the code. But we're not going to edit it locally. We're actually going to edit it as if it was only sitting on that node. So you actually could run git commands on the remote server, do your work, push it back out, and you would never have to do any file mounts. I did it this way just because I could. Okay, so the thing to do, the easiest way to do this is I have a Docker Compose for DASK here. If I just right mouse on that and say Docker Compose up, okay, so that's going to bring up my 4 nodes that I talked about before, and they're up. So if we come here, we can see that the nodes are actually up. And we can see the number of workers. And I can make that bigger. Right? So we have 16 threads, 2 worker nodes. You know what? Let's leave that a little bigger so we have that for later. We can see there's no tasks running. There's no graph of previous execution. And the status shows nothing. Yay. Okay, so what we're going to do, if we look in Docker now, we can actually see in the plugin that there are 4 nodes running, right? I'm actually eventually going to connect to this notebook server. So what I can do here is I can say, attach Visual Studio Code. All right, so I'll bring this guy over here. All right, so what it's doing is actually making a connection out to the notebook server through the usual Docker backchannel stuff, like if you got it enabled. And what we can see here is that we can see this is the same Docker view we have on the other one. We're like, hey, what modules are installed? So on the remote server, we don't actually have anything installed. What you can do here is you can start to install Visual Studio Code plugins in the remote server so that Visual Studio Code will actually be running the debugger and everything remotely against the code remote. And then this will just be a view that we're looking at right here. So I can say, hey, I want Python. So you'll see this thing here. It says, install this in the container. Yes, we're going to, and it's installing. So there are other things. Let me think. Is there any other Python thing I want here? No. So all I'm going to do is install the Python plugin that lets me do Python editing and debugging. I'm trying to think if there's anything else here I wanted, like Docker. Nope. Okay, so that's the only plugin I'm going to install. So I'm going to get out of that, and you can see that we have a reload required. So what's happened is Visual Studio Code has installed a temporary server in the remote host, right? It's actually installed Visual Studio Code install right here. And now we're going to restart that server to make the plugin work. So we'll do restart required. And we can see that the plugin is now, so now we have a multi-threaded blah, blah, blah Python at capability running in that. And the reason I want to do that is I want to be able to run Python commands, right? So if we look at the code that's out there, ooh, no code. So let's go look and see if we can find code out there. And it's here. And it's here. And I went too far, so we'll go back up one. GitHub. Oh, right. I want playground, because I'm an idiot. Okay, so there we go. So we can see here that this turned from purple where it was before to blue. That says we have files open. So now we are on the container with files open with our IDE connected to it. Oh yeah. So if we look at this simple DASK example, and we remember this time to uncomment out the totals. This is a blocking read. The previous video I didn't comment this out. I left it commented out, so I thought it was super fast, but it was actually still running, and then we always looked at it running and going, oh, wow, that's kind of interesting. So this is a blocking read to gather the results. So what are we going to do? We're going to square a number, then we're going to negate it, and then we're going to sum it. So we created a couple functions, and we did distributed map calls to square everything between 0 and 10,000. And then we're going to map, negate each one of those, and then we're going to gather the results in the total operation with a future call to sum the results of these. So we create a feature vector, right, of 10,000 results, and then we're going to sum all those to get our final feature. And then this is the blocking read that actually gets those results. So if we save that, we're actually on the server doing this. What I can do now, so what we can do now is I can run this Python file in a terminal. Now, if you're doing graphics calls and you did visualizations and stuff, you can actually run Python in an interactive window, and it'll do all the graphing and stuff for you. Okay, so we're going to run this. No such, right? Oh, right, Python's in the wrong place. So we'll just, let's do this. I think Python and the Python home is not where we thought it was. So let's go do this. Nothing like a demo you haven't practiced. Okay, so if we can just go here and say Python. That did not, oh, %time, right? Because I did that in a Jupyter notebook. So let's do. You can have IntelliSense turned on here too. I didn't do it. All right, let's try it again. All right, so it's out running. Let's see. Yeah, so what's happened is we got these maps, these square and the neg calls going out, negation, right? And then it's going to sum it. You can actually see the workers running here, worker 2 and 1, and now we're probably done actually, or now it's doing the sum. So we actually fan all the work out to the 2 nodes to do the map calls, and then the summing is all done on 1 node. So we can probably go see that real quick. If we come over here, you can see that we were in the sum call, and oh, we missed it. Okay, so let's run it one more time, and you'll get an idea how this works. Let me look at the tasks. So we had done, how many? Let's go look. We had done 10,000 map calls for, created a vector of 10,000 long, right? So the green is the map call, and the yellow is the sum. So you can see a bunch, because we have 32 threads running, there will be 32 rows here, each doing some subset of this operation. The green is the multiply, squaring, which is multiplication, and the yellow is the summing, and this is the data gathering at the end, right? So this is the transferring the sum, and this is actually reading the sums and doing stuff with it, okay? And this one way out here is what? Transferring the negative. Oh, because it did the negatives. Okay, so let me run it again, and we will watch this thing fly by. So I'm just going to run this here, and this is all my fault. You'll see here it said no Python interpreter selected. If you select the right Python interpreter in the right place, then you won't have to do this thing by hand. I did. The demo god of heck. Okay, so if we sit here, we can see it's running here, right? You can see it flying by here. This is actually doing all the squares first, and then it goes into the sum phase. And then it will run this task processing. This is actually the next task, which is single threaded, because it's actually got to do the sum, so it's got to pull all the results back, and boom, we're done. And that's it. And so that's all it takes to run, to bring up Docker Compose with a distributed Python environment using any Docker Compose file you got, but you can pull the one from my repo. And then the other part you can do here is I actually am on the box connected to the Python server that was part of the distributed cluster, and we edited and made a couple mistakes and then had to run the code. Like I said, in this case, it's actually mounted from a GitHub directory, but you actually could have run Git right on it, and it will make that connection from the Docker container and then pull the files in, and then you could commit it. And that's it. So I hope you found that interesting.